Alrighty folks, good day to you. We're talking about sequences today, or patterns as they are commonly referred to. I hope you can see me. The camera looks kind of tilted, so maybe I need to stand up this way. Anyway, hopefully you can see me. Sequences are basically a set of repeatable steps. We see them usually with numbers, and sometimes you can see sequences that are that use shapes. I used a couple of examples recently that involve letters. It can be pretty much anything, but it has to have a repeatable, a predictable, I guess you could say, rule. So we're looking for the rule in a sequence, but we're also trying to use that rule so that we can make the pattern go on, or we can extend it. I like to say that our job with patterns is to extend and also explain. And hopefully you could do both of those by the end of this lesson, and hopefully by the end of this academic term. And you've seen patterns before. This shouldn't be nothing new, but hopefully this will be a unique spin on it that you can take with you. We have some examples here: 10, 20, 30, 40, 50. There is a repeatable rule there, and I wonder if you know that. Do you know that rule? Well, I hope you've said it either in your head or out loud. Out loud might make it sound kind of foolish, but in your head at least, that this is increasing by 10 each time. And I'm looking at this number to this number, this number to this number, this number to this number, and this number to, no, it's 50. Anyway, we're increasing by 10 each time. And I can write that, and I can continue to write that, and I can call that my common difference, and we'll get to that in just a moment. There are things called common ratios, and that is just another way of explaining the pattern as well. And that is exemplified in a pattern like this, where you see 2, 4, 8, 16, 32, 64, and it keeps going on. Because this number is doubled to get this number. This number is doubled to get this number. And it continues on. So it's just another way of explaining a pattern, either a common difference or a common ratio. And we have another example here. I'll let you figure that one out for yourself if you get a chance, and I'll look forward to talking to you about that in class, because this is your notes. We're moving on in 3, 2, 1. Didn't drop it. Oh, I did drop it. Ow. That was not planned. And it's fixed. Hopefully you can see it. Can you see it? Yes, you can see it. You might need to make the video kind of big so you can see everything. And no, that did not hurt. Pause for laughter. Moving on. So, we have some sequences here, and like I said before, I want you to be able to explain sequences, and I want you to be able to extend sequences. Follow the rule, identify the rule. And I gave you a couple of examples here. I have 4, 7, 10, and 13. How much is this pattern increasing by each time? If you said 3, you're making sense. If I take that rule and I extend it, my next number is, and my next number is, and my next number is, and I can keep going if I want to. What about for this one? It says common ratio, and it says commonly you're going to deal with either multiplication or division with a common ratio. Same thing with common difference. You're going to deal with addition and subtraction. What's going on here? 7 to 14, 14 to 28, 28 to 56. If you said multiply by 2, or doubling, then you'd be correct. I'm explaining the pattern, and now I am extending the pattern. What's 56 times 2? What's that times 2? And I'll let you tell me in class. Sequences are about explaining and extending. If you can do both of those, you're well on your way to understanding this. Have a good day.